Greatest common factor. In this video, we're talking about how to find the greatest common factor of a few monomials. And we've been given three examples. In the first example, we've been asked to find the greatest common factor of our three monomials, 5, 10, and 20. Let's just go ahead and clarify a few terms here. Monomials means just one number. Mono means one, and mil meaning number. So monomial is one number. So 5 is one number, 10 is one number, and 20 is one number. So these are three monomials. And we've been asked to find the greatest common factor among these three monomials. The greatest common factor is going to be the largest number of factors that divide evenly into all three of our monomials. So what we want to do to find the greatest common factor? At least most basic level, and we will get faster at doing this as we get more practice. But what we want to do is break down each of our numbers into their prime factors. Then we will take all of the factors that these numbers have in common and multiply them together to find the greatest common factor. So here's what that looks like. 5 broken down into its prime numbers is going to be just 5. 5 is already a prime number, so the only factor of 5 is going to be 5 itself. 10 broken down into its prime numbers will be 2 and 5, and 20 broken down into its prime factors will be 4 and 5, and 4 can be broken down into 2 and 2, so we can't go any further. With the monomials broken down into their prime factors at this point, we're looking for the factors that are common to all three of our monomials. So if we start at this 5, so is this 5 in our other two numbers? Yes, it is. We have a factor of 5 here and another factor of 5 here. So because this factor of 5 sort of matches across all three monomials, it exists in. If you look at this next factor here of 2, we can see that we have this factor of 2 involved in the breakdown for 10 and 20. But we don't have a factor of 2 involved in the breakdown for 5. So we can't include it in our greatest common factor. Nor can we include this sort of a second 2 that is involved here in 20. But again, we still don't have a factor of 2 involved in our breakdown for 5. Which means that the only thing we can include in our greatest common factor for 5, 10, and 20 is 5. So the greatest common factor for 5 and 10 and 20 is going to be 5. Which means this is the largest value that can go evenly into 5, 10, and 20. Let's go ahead and look at our second example here. We've been asked to find the greatest common factor of our two monomials, 105 and 70. So let's break these two down into their prime factors. 105, I can write it as a 21 and 5. So 21 times 5 is equal to 105. 5 is a prime factor. 21 is a composite number, so I can go farther and open it to 3 and 7. That 3 times 7 will be 21. Now, 3 is a prime number, 7 is a prime number, and 5 is a prime number. So we can't go any farther. Let's go for 70. We can open it into 10 and 7. 7 is a prime number, but we can continue with 10 and open it to 2 and 5. 2 times 5 is equal to 10. Now we're done with the factorization. With the monomials broken down into their prime factors, at this point, we're looking for the factors that are common to our monomials. So as you can see, we can include 5 and 7 in our greatest common factors. We can see that we have these factors of 5 and 7 involved in the breakdown for 70 and also involved in the breakdown for 105. But we cannot include 3 because, as you can see, it's not common between our monomials, so we cannot include it in our greatest common factor. Nor we can include this 2 that's involved here in the 70, but we still don't have a factor of 2 involved in our breakdown for 105. Which means that the only things we can include in our greatest common factors for 105 and 70 are 5 and 7. So the greatest common factor for 105 and 70 is going to be 5 times 7 equals to 35. Which means this is the largest value that can go evenly into 105 and 70. Let's go ahead and look at our last example over here. More complicated example. Here we have the three monomial numbers 6a, 6a squared, and 12a cubed. So we've got now a variable involved, and we need to break these monomials down first by looking at these constant coefficients. So first we will look at 6, 6, and 12. Then we will look at the variables for a. So if we break down 6 into its prime factors, the factors are going to be 3 and 2. If you break down these 6 here into its prime factors, we're going to get a 3 and 2. And if we break down 12 into its prime factors, we'll get 4 and 3, and then break down 4 into 2 and 2. So 2 times 2 times 3. So what we will end up with is 3 to 2. Now we need to look at our variables here. We have just a single factor we can't break down any further, so we have this factor of a here. We have a squared, which we can break down into a and a. And here we have a cubed that we can break it down into a times a times a. So now our monomials are completely break down into their prime factors, and we need to go ahead and look for common factors. So if we start with this first factor in 6a, we have 3, and we can see that we have 3 and 3. That factor is common to all 3 of our monomials, so we can write it down here. We can see also that 2 is a factor which is common, so we can pull that out. We have this extra factor of 2 for the 12, but we don't have that extra factor of 2 involved in either of these first 2 monomials, so we're not going to be able to pull that out. So we're going to go ahead and skip to a. We know that we have a common factor of a in all 3 monomials, but we don't have a second factor of a or a third common factor of a, because even though there's an additional a involved in 6a squared or 12a cubed, we don't have another factor for a to pull out of 6a here. So that means that all we can take is the 3 and 2 and 1a. So we can pull those 3 things out. What we're going to do is multiply them together. And when we do that, we're going to get 3 times 2 times a is 6a. So we get a 6a as our greatest common factor.